Imagine standing at the equator. Not the jungle-hot, humid equator you know, but one buried under a mile of solid ice. No ocean, no breeze, no sound except the slow, grinding moan of a frozen planet turning in the dark. This wasn't another world orbiting a dying star. This was Earth. And it stayed this way, completely frozen, for nearly 50 million years. No thaw, no spring, no seasons. Just white. Scientists call it Snowball Earth, and it didn't happen once. It happened at least twice. Today, we're going back 700 million years into the deep past to understand how our planet nearly killed itself before complex life had even had a chance to begin, and how, against every odd, it came back. So how does a living, breathing planet freeze solid? It started with something that sounds almost innocent. Around 720 million years ago, Earth's continents were clustered near the equator, a configuration that changed everything. When rocks are exposed to rain, they weather. They pull CO2 out of the atmosphere through a process called silicate weathering. Normally, this is Earth's natural thermostat, a slow, gentle balancing act. But with so much landmass concentrated in the tropics, the weathering went into overdrive. CO2 levels dropped, temperatures fell, and then the trap sprung. As the planet cooled, ice sheets expanded. And here's where it gets terrifying. Ice reflects sunlight. The more ice, the more sunlight bounced back into space. The more sunlight lost, the colder it got. The colder it got, the more ice formed. A feedback loop, a runaway train with no brakes. In geological terms, it happened fast, perhaps in just a few 100,000 years. The oceans at the equator, which had been warm and teeming with microbial life, began to freeze. First the surface, then deeper, then solid. Earth had become a mirror. Imagine what this world looked like. A planet the color of bone. The atmosphere bone dry and brutally cold. Temperatures at the equator plunging to minus 40 or 50 degrees Celsius. Colder than Antarctica today. Colder than almost anything alive on Earth can survive. The oceans locked under ice potentially a kilometer thick in places. No waves, no tides visible from above. Just a vast white silence, broken only by the groaning of ice under its own weight. The sky above? Probably crystal clear, brutally so. Without the water cycle running normally, clouds rarely formed, so the sun rose and set each day over a planet that reflected it almost completely away. 60% of incoming sunlight bounced back into space. The planet was in a death spiral. And yet, life did not disappear. Here's one of the most remarkable things about this story. Some of the most extreme survivors in Earth's history clung on in pockets of possibility. Volcanic hot springs, where geothermal heat kept small liquid pools open even through the worst of the freeze. In these tiny oases, microbial life persisted. Bacteria and algae huddled around heat vents on the ocean floor and at volcanic islands, holding on in the dark. There's also evidence the ice wasn't uniformly thick everywhere. In some equatorial regions, thin patches, maybe just a few meters deep, may have allowed just enough sunlight through for photosynthesis. A dim, blue-green world beneath the ice, still and silent, but alive. These survivors mattered enormously, because when the thaw finally came, they were the seed stock for everything that followed. But we're getting ahead of ourselves, because first, the planet had to break itself free. Earth was trapped. The very thing that caused the freeze, low CO2, kept it frozen. Because ice reflects sunlight, there was no easy way out. A partially warmer planet would just stay frozen. The feedback loop held the ice in place like a lock. But the planet had a secret weapon it had been charging the entire time: volcanoes. Here's the thing about a frozen planet: the geological machinery underneath doesn't stop. Tectonic plates keep grinding, magma keeps rising, volcanoes keep erupting, and they keep releasing CO2 into the atmosphere. In a normal Earth, this CO2 would be absorbed by the oceans and weathered away by rain and rock. But on a snowball Earth, the oceans are frozen, the land is buried, there's almost nothing to absorb it. So it just builds. Million after million after million of years, the CO2 accumulates. Climate models suggest it took hundreds of times today's concentration to finally crack the ice. We're talking about a greenhouse effect so extreme it would be unrecognizable to us today. And then, a tipping point. At some threshold, the atmosphere becomes warm enough to start melting the ice at the equator, just slightly, just enough. But once it starts, it accelerates, because now the feedback loop runs in reverse. Less ice means less reflected sunlight. Less reflected sunlight means more heat absorbed. More heat means more melting. What followed was probably the most violent climate swing in Earth's history. From global glaciation to a hyper-greenhouse world, possibly within just a few thousand years. The oceans, finally exposed, absorbed enormous heat. Water evaporated in towering sheets. Storms of a scale we cannot imagine today would have swept the planet. Torrential acid rain, because all that CO2 combined with water vapor came crashing down on the ice, dissolving it at an extraordinary rate. The planet went from snowball to sauna in geologic eye blink. And the seas ran with something extraordinary: thick, rusty streaks of iron. Billions of years of iron deposits on the ocean floor oxidizing all at once as oxygen re-entered the deep water. The banded iron formations, layers of red rock, are literally the frozen record of those chaotic seas, and geologists find them on every continent. They are the scar tissue of a planet that barely survived. The ice was gone. Earth sat, stunned and steaming, under skies loaded with CO2 and water vapor. The oceans were warm. The continents were scoured clean, and something remarkable began to stir in the shallow waters. Life, which had clung to existence in hydrothermal vents and thin ice refugia, began to expand. But this wasn't the same world as before. The stress of the snowball, millions of years of brutal selection pressure, may have accelerated evolution in ways that gentle, stable conditions never could have. The survivors were tough, adaptable, capable of withstanding extremes. And around 540 million years ago, shortly after the last snowball event ended, the fossil record explodes. The Cambrian explosion. In a geologically brief window, nearly every major animal body plan appears in the fossil record simultaneously. Eyes, shells, limbs, symmetry, the architecture of modern life appearing almost all at once. Was the snowball Earth directly responsible? Scientists still debate the exact connection, but the timing is striking, and the logic holds. A planet scoured, reset, and rewired, with oceans freshly oxygenated and nutrients unleashed from billions of years of frozen rock, would have been a remarkable incubator. The most violent chapter in Earth's history may have been the prerequisite for us. Think about what this means. Every tree, every animal, every human being who has ever lived, we are all here because a frozen planet refused to stay frozen, because volcanoes quietly exhaled CO2 into an empty sky for tens of millions of years until the ice finally broke. We are the children of a catastrophe, and we carry the evidence in the rocks beneath our feet, ancient glacial deposits sitting right on top of tropical limestone, a geological impossibility unless you know the story. The story of a planet that became a snowball. and chose to be something more. If you made it this far, thank you, genuinely. This is one of those stories that completely rewired how I think about life on this planet. If you want to go deeper, I'd recommend looking into the Marinoian and Sturtian glaciations, the two main snowball events, and the work of geologist Paul Hoffman, whose research in the 1990s brought this theory to mainstream science. And if you liked this video, the next one is going to hit just as hard. I'll see you there.